Well, hey everyone, how's it going? I've been asked quite a bit lately. Ever since I modified this 8,000 watt PowerJack unit, I've been asked, how did I modify it? I did in several ways. Number one, cooling. Put a much larger fan in here, a fan filter, and I put a dedicated fan switch on top. Now, the unit did in fact come with a little toggle switch, which is fine. But the size of the fan that I actually put in, the amount of current that it actually would draw, far exceeded that little toggle switch wire that was running down there. And so I just decided to replace the whole thing. Put a heavy duty 15 amp power switch here. It's a two-way power switch. It's just a toggle on and off. And it lights up when it's on. But anyway, I been kind of talking with several people actually who've had questions about how I modified this thing. And so I would like to show you guys exactly how I modified it. This is my first unit that I modified. I've actually modified several of these. I did my 5,000 watt unit and then I sold it. And I'm getting ready to actually sell this unit. For those of you who don't know, I've upgraded my system to 24 volts. And PowerJack was kind enough to send me their very large and 2017 edition, the 15 kilowatt home replacement unit. I'm still battling YouTube on copyright issues, which I can't understand. But anyways, so in the meantime, I figured I would go ahead and show you the modifications I've done to this. I actually have a buyer who's going to be buying this real soon here. So I want to go ahead and show you this. Again, this is the first one that I modified. So I've changed things up a little bit. I used shrink tubing for some of the connections, whereas in this version here, I just used electrical tape. So it looks a little bit more crude, but it works just fine. So why did I modify this? Well, first of all, I believe that the stock fan that is in these, especially in the 12 volt units, is inadequate to be able to cool this. You're talking about a confined space because there's almost no room on the inside here. And yes, this whole unit can kind of act like a heat sink, but even with the air that it's pushing through, it's just inadequate because there's so much stuff on the inside. And of course, I'll open this up and show you, but with it being so tightly packed, if you're a PC gamer and you build computers, you know that adequate airflow is critical to keeping your system cool. And unfortunately, I think with this design here, there's no way to really overcome the issues of having so much stuff in here and it trying to move air through here, because as the components heat up, it has to bring air across and then eject it out the other side. And when you have so much stuff blocking that air, yes, that air is eventually going to make it out there, but the speed of the fan, the stock fan that is, and the fact that it's so packed in here doesn't allow for much heat to actually get out. On top of that, where the fan is positioned, which is positioned on this side here, you've got your AC to DC, or actually DC to AC converter here in this area here, which is the main board. That gets hot itself with all the MOSFETs heating up. All that heat is then pushed across the transformer, which is right here, which gets hot. So you're essentially taking hot air and pushing it across something that's already getting hot, and it's not really cooling the transformer, which is why these tend to shut down, especially the 12 volt versions. They tend to shut down because they overheat. For thermal protection, they shut down, which is why a lot of people complain that they turn on their air conditioner or something like that, and then after 30 seconds they shut down. Well, a lot of it has to do with cooling, and all the testing that I did with this particular unit after I modified it, not only with the fan, but I also removed all the charging components, I was able to sustain much larger, much longer draws. And I have sent this information to PowerJack because I worked with them real closely with their new 2017 units. I did, tell them, hey, you need a bigger fan in these things, and increase the cooling capacity. So I don't know if they're going to change that for the replacement units for this or not in the future, but hopefully they will. So anyway, and yes, I did remove the charging components on the front here because they take up a lot of room on the front and they block a lot of air. And I did notice it was about a 5 to 10% drop in temperatures. Not scientifically measured or anything, but about a 5 to 10% drop in temperatures with the same load on the transformer when I removed the components for the charging sections, okay? So all the input has been removed, and I obviously removed the toggle switch, I removed the charging fuse, and so it's been cleaned up. There's a lot more output as far as airflow, and that did, in fact, improve cooling slightly. And also I sent that information to PowerJack, and I'm hoping that they will release their units without the charging capabilities. It'll save them money, it'll save you money, and it'll improve the efficiency of the inverter overall, because I personally do not use the charging capabilities of these units. I actually use a dedicated battery charger, a solar charge controller, and I don't rely on the internal charging capabilities or the battery ups that is featured with these units. It's nice for emergency backup, it's great, but I never use it because my solar panels are charged independently of the inverter. So anyway, enough talking. Let's go ahead and crack this thing open, and I will show you exactly how I modified this. Okay, so I'm not sure how well this is going to show up on camera, but I'll go ahead and show you the stuff that I've modified. So I told you I took out all of the charging capabilities of the inverter. You can see here that there's a couple of terminals here for the input. That's 120 volts in that allows it to charge the battery. Basically what it does is it uses your house current. So you run, usually you run just a plug in the wall to the front, and that allows you to use 120 volts house current to charge the batteries. If you have a much larger battery bank and it requires more charging, then this also features a direct 120 volt input. You wire it from your breaker box, and that allows you to be able to set up a dedicated 15-20 amp breaker at 120 volts, 115 whatever, to charge the batteries. So there's two ways to obviously do that. Now I removed all that. I removed the wire that ran to that. I also removed the plug, the connectors, the fuse. There's a dedicated fuse just for the charging. I removed all that. Again, that's all to increase airflow. So that was my goal, because I don't use the charging capabilities anyway. I just said, basically to hell with it. And again, hopefully PowerJack will actually make one of these that removes all the charging features of these inverters. So we'll just have to wait and see. You can see here this group of wires that's right here that I've actually added, and there's blade fuses that are in here, and the blade fuses are obviously there to protect against shorts, to start, that's obviously going to start a fire, and so that's something that I wanted to make sure was done. So this one here is actually the positive that goes to the fan. So this would be the positive fan connection. This one here is the negative fan connection, as well as the negative battery terminal, which is right back here. So that allows it to make a closed 12 volt connection. So these are tied in together. I just used some shrink tubing, and again, as I mentioned before, I've just got some electrical tape on here. The only reason I have the electrical tape on there is because of these end connectors that are exposed, and I didn't want anything to possibly short out on maybe the heat sinks or whatever. So that was just for me. It looks kind of crude, but it's there basically just to help keep the connections insulated. And then the other one that's right here that also has a blade fuse on it goes to the positive terminal on the battery connection internally. So you have a hot source that runs into the switch, and then you have a hot source to the fan, or an output to the fan. So when the switch is turned off, then this source, the power source, is actually cut off. When the switch is turned on, the power from the positive battery terminal is then sent through to the positive terminal on the fan, and then obviously the connection on the ground never changes. So let me go ahead and show you the fan switch. Now obviously you guys can see this 2-position toggle switch that is illuminated. So there's 3 positions here. You've got the fan positive, so that's your output to the fan itself when the switch is activated. You've got your battery positive, which is the source of the power, and then you've got your battery negative, which is obviously the negative loop, okay? And so when the button is pressed, then a connection is made, the fan turns on. It's pretty simple, actually. So these 12-volt units in particular, the 24 and the 48 volts, don't suffer the same, at least they're not as bad as far as thermal efficiency. You've got this big transformer that's right here, and you can see how tightly compact it is. PowerJack, they did a good job packing these things, okay? Because they go overseas, they're very heavy, so they're usually manhandled. And so by really securing the parts down to these units, they actually did prevent damage during shipping. And once you get it on your bench, if you're not actually using this in a car, which would be ridiculous, hooking up a car battery to this and expecting to power much at all, you should be using deep cycle batteries. But anyways, once you get it on your bench, then you can actually remove this stuff. The insulator that's here, the insulation pad, that can be removed to allow more airflow. And there's other things that you can do, because the transformer itself doesn't require this stuff. This is just an insulation pad. It's for vibration, as well as insulating it from whatever else may be on here, like this plate on top. This is PowerJack doubles this as a thermal plate, so it actually has a temperature sensor right here that senses the temperature of the transformer, and I believe when it hits 35°C, then it will actually turn on the fan. Now, I have obviously bypassed all that. I still have the thermal switch hooked up because the unit seems to act weird, or at least this particular unit seems to act a little bit differently when I had this disconnected. I was getting far more thermal shutdowns with it not activated. I don't know if it's because the CPU just didn't see and it assumed that there was something wrong, so shut it down for safety. I'm not really sure, but so I kept this plugged in. I kept it right here, and I've actually had this plate off and sitting outside of the unit, and it never shut off. So I think it's just a fact that it has to sense this sensor here, and if it doesn't, then it shuts itself off. So I went ahead, obviously, and I left that. And then the manual fan switch, which is right here. There's actually the thermal switch. It's actually right here. This has a thermal fan switch, so that runs to this board right here. And when the temperature reaches 35°C, actually this is 30. Yeah, it's 35°C. So when it reaches 35°C, then it automatically activates the fan. Okay, but in my opinion, even if you have very low draws, a few hundred watts, a couple of amps, this thing, there's such a delay on here that I've found, and I've got a thermometer, a laser thermometer that I tested this with to see, and it's not just the transformer that can actually heat up and then damage the inverter. You can see how big these heat sinks are that are cooling down these MOSFETs. Okay, the MOSFETs get hot by themselves, but you've got this big, huge heat sink here that usually keeps them pretty cool. The problem is that they can get pretty warm before this transformer will actually get warm. And what can happen is the transformer may still be within its range, but the MOSFETs are getting so hot, and then you take that extra spike or that draw, or your fridge starts, or your central air, or something like that will start up, and it'll blow all these MOSFETs because they were already really hot to begin with, but the thermal fan is connected to this transformer right here, which may be cool enough and fine, but your MOSFETs are actually really, really hot, and the fan's not running, so when it takes that extra spike of draw, then bam, you blow your MOSFETs. So as a general rule, you should always have the fan in the on position, manually on. So that's why you can see that this here is disconnected, because that thermal switch is useless to me. And I think it should be useless to anyone. I know why PowerJack did it. They did it because they want to have a convenience thing. It's kind of like a transmission in your car shifts really smooth, yet that wears down the transmission more because there's more friction on the clutches. So that's why a lot of people use shift kits and so on. So you get that nice, hard, firm shift. Clutches have less travel, so they generate less heat, they lose less material, and whatever. So it's the same thing with this, is they wanted to make it convenient, they wanted to make it quiet, they wanted to make the draw less, even though the stock fan draws only a few hundred milliamps. I mean, it's very small. So I know the reasons behind doing it. I just think that, especially for the 12-volt units, they really need to step up the cooling for these things, because there's just not that much room in here, and many people do not understand the laws of physics when it comes to thermodynamics and so on, as far as how heat works and the conversion process when you're going from 12 volts all the way up to 220 volts. That's a hell of a conversion. That's a lot of amps rolling through here, and it generates a lot of heat. That's why the 24 and 48 versions don't generate as much heat. So those who are really serious about being off the grid will usually go for a 48 volt unit. They're more expensive, but they will usually go for a 48 volt unit because they do in fact generate less heat. But of course, it requires 4 batteries instead of 1 if you've got a single battery bank. 4, 8, 12, 16 batteries, because you got to wire them in 48 volts. It requires 4 solar panels instead of just 1 solar panel, because you got to wire those 12 volt solar panels in to 48 volts. So overall, in order to get the results, you've got more stuff you got to buy at the bare minimum, but at the same time, your battery bank is going to last, just the same amount of time, because 12 volts converted to 120 volts or 48 volts converted up to 240 volts with 4 batteries instead of 1. It works itself out. Those of you who don't quite understand, there's a lot of information on that. I converted to 24 volts myself. I've got 8 batteries wired in 24 volts. So anyway, I know I'm babbling a lot, but I have about $50 in parts here. It's important to have fuses on all of this stuff, okay? You are essentially taking the batteries, okay? This is a direct draw from your battery bank. You're essentially taking that and powering the fan with it. So you need to have a fuse in there. Not only a fuse leading to the fan, but you also need a fuse that is leading to the battery bank. So if there is a short of some kind, this fuse blows, you're fine, you're safe. You also need a switch that is going to be able to handle the amount of draw. This fan here is actually a 2 amp. That's 2 amps DC fan. That's huge. I think the stock one in there is like 300 milliamps or 400 milliamps. So it draws a lot of electricity. So you want to have a switch. This is actually a 5 amp switch. So it's more than enough for this fan. It's a 5 amp switch. It's a single toggle. Well, it's a on-off switch, so it's not a 3-way or anything else like that. And I got that on Amazon, I think, for about $8 or $9. But this is a heavy-duty 5-amp switch, so the switch itself won't overheat. And then you can see how I wired the wires here. With 2 amps going through wire, even at this is 16 gauge wire, that's fine. It's only 2 amps at 12 volts. It's not really gonna hurt it all that much. It's adequate, basically, more than adequate. So anyway, you got to make sure that you follow the safety precautions, because when you do something like this, you want to make sure that nothing's touching. Like, for example, I cannot actually plug this stuff in because the wires are short enough, because I didn't want to make wires super long because that would negate all the work that I did for trying to keep it cool. So I made the wires as short as possible. So basically the only way that I can plug this switch in is to have the lid actually almost basically on, and then I reach up underneath and plug everything. But how many times do I take the lid off? For me, I'd rather put a little bit more work into that 1 or 2 times that I might ever have this lid off, than to have a whole bunch of wire in here just for the convenience of being able to plug it in while it's, or keep it plugged in while the lid is off of the unit. So anyway, I don't really know what else to say. This fan here, again, this is a very large fan. It is 200 CFM, okay? 200 CFM, it's very loud. It sounds like a jet engine. Again, that's another reason why I think that PowerJack went with a smaller, quieter fan, so that people didn't turn these things on and they sound like a jet engine. But for me, I don't care how loud it is, as long as it stays cool and doesn't shut down on me. So personally, not everybody's like this, but personally, I would rather have a louder unit that's going to keep cooler than have a quieter unit that's going to overheat, especially in the summertime when there's some heavy draws. The ambient temperature in the room is going to be higher. It's very important to me to keep these things cool. And maybe possibly in the future, PowerJack can give you some options for, I know they want to keep their overhead as low as possible, but, bump it up a little bit, or have a variable speed, variable fan controller on here so that you can, if you need to turn it down for any reason at all, then turn it down. But I would like to see them improve the cooling capabilities of these particular units here. They're pretty good like they are, but everybody knows that PowerJack's reputation for these things is that, pretty much as soon as you start to really crank on these things, they get hot and shut down, especially the 12-volt units. Yes and no, it's kind of the fault of PowerJack, but it's kind of one of those things is, what do you expect? Out of 12 volts, 8 kilowatts draw. That is an enormous draw on your battery bank. You need to have a battery bank that is super beefy, super large, dozens of batteries, and very large batteries, at least 2,500, probably 3,000 amps of power. I'm not talking about cold cranking amps. I'm talking about amp hours. So, but anyway, so that's pretty much it. It's actually not that difficult to do. Oh, I did one more thing is I added a dust filter on the end of this. You could just get these cheap 120 millimeter dust filter, computer fan dust filters, real cheap. I think I paid like $5 for 10 or 15 of these dust filters. So that keeps the dust out of this unit here, and you're still going to get dust. You can see I don't think you can see that, but there's still a little bit of dust in here, but it's not bad. That's just dust rolling in from the front of the ventilation here. That's not actually dust coming from the fan, or at least not as much, okay? You're still going to want to take these things apart about every 6 months to a year, depending on its use, and just kind of clean it up, vacuum it out. Just obviously make sure that you don't have your batteries connected when you're doing stuff like that. So that's why I don't have anything connected right now. The capacitors are all discharged, and I'm getting ready to sell it. So cool. If you have any questions, let me know. Again, like I said, it's about $50 in parts, and I noticed a substantial increase in performance of the unit itself. So it's one of those things that I wanted to invest the $50 to make sure that the unit itself didn't become damaged or shut down. And I know everybody has their opinion on PowerJack and what they should and should not do, blah, blah, blah. That's fine. I've made my suggestions to them, so hopefully in the future they will modify the design and beef up the cooling. And yeah, we'll have to see. All right, so I did want to demonstrate before the end of this video that you can in fact wire this particular switch to stay illuminated all the time, which I've shown you right here. The switch itself comes with instructions. You should know how to do it if you read the instructions. I also have my test bed here. This is my 12-volt test bed because I do actually work on these units. I can't keep switching to battery all the time, so I have a 12-volt power supply here that I use to actually test these units and test their output and input and efficiency and things like that. So I've got that hooked up right now, and you can hear so that is a very loud fan. Obviously, PowerJack's probably not going to put that size of a fan in there, at least that speed. But if you're serious about cooling, and I think PowerJack should take this a little bit more serious, that noise is going to happen when you have something in such a confined space. That big 15 kilowatt unit has 3 fans. They're slower, but the 3 fans actually move air a lot more efficiently because not only is there a lot more space, but you have 3 fans versus just 1 fan, and it stays very cool. It actually really does. I've done a lot of testing, and so these units, there is a 15 kilowatt unit that is the style like this that PowerJack does sell, and it has 3 fans. You've got 3 transformers, or there might be 2 if I'm not mistaken, but you have 3 fans internally. That's fine for helping push the air out, but again, you've got the problem of having such a confined space that it's really difficult to keep that cool. So this fan here, okay, so that's going to draw about 1.5 amps to 2 amps. You know, it all depends on your battery bank, where the voltage is on your battery bank. This keeps it at a constant 13 volts. But that's going to draw up to 2 amps from your battery bank, so that is a disadvantage. If you have to scrape for power, that is, you're on a very limited supply, then having a fan this large is probably not going to be good for you. But again, why would you have such a small battery bank with something that can produce, or claims to produce, 8,000 watts? So you have to also take that in consideration. Don't buy this massive inverter and have one little itty bitty battery and one tiny 50-watt solar panel and expect to be able to power your entire neighborhood. It ain't going to work. So if you have a large battery bank and you want to use this inverter, that 2 amp cost to have this thing, you know, basically running while you're generating electricity, it's, you know, it's just a cost of, it's basically a cost of being renewable. That's what it is. It's an investment. So the unit stays nice and cool. You can produce more with it because it won't shut down. And yes, the fan is louder, but I mean, this thing, when I had it up and running, sat in the laundry room. I mean, I got a washer and dryer in there. So, I mean, why am I worried about noise? So anyway, that's just something to consider. And yes, the unit does in fact work just fine. This is a manual switch, so the unit is on now. I don't know if the camera can pick up that LCD, but it's running at 228.9 volts right now. And it's got a draw of about 0.33 amps. So you turn that on. Voltage drops just a tad, ever so slightly. Whoops. So, yeah. But anyway, So anyway, that's pretty much it. I mean, yeah, it's a loud fan, but I guarantee you, and based on my testing, you can really push these things with this modification. Cut out the guts, all the wiring for the charging portion, get rid of all the stuff on the front end that you don't need, and then install a very large fan with a dedicated high amperage fan switch. And you will really be rocking. I guarantee you, you're going to be able to push these things much, much further than you could without this cooling system. So, like I said, maybe in the future, PowerJack will actually consider that not very many people care about how quiet they are and care more about performance. So we'll see. We'll see what happens. So anyway, just wanted to add that on to the end of the video. So if you have any questions, let me know. Take care.